All right, hey guys, so we just talked about the GCF and how to find that, but we're actually are going to be factoring out a GCF, and we haven't talked about factoring. Factoring is turning something into a multiplication problem, as it says here. Factoring is also the opposite of distributing. So if I give you a problem like this, let's see if my thing works, yeah, 2y, and I'm just going to do it right here, 2 parentheses y plus 3. We know that there's no sign in between the 2 and the y, and parentheses means multiplication, so we know we need to distribute here, right? 2 times y is 2y, and then 2 times 3 is positive 6. So if we were to distribute this or expand or multiply, it also says multiply here, then we would get 2y plus 6, which is what I got right here. So this is expanding, it's distributing, or it's multiplying, right? This from this step to go to this step. Well, factoring is going to be the opposite of that. So that means we're going to go from something like this, 2y plus 6, it's an addition problem, and turn it into a multiplication problem. And to do that, you have to factor. And this is not easy. So it's pretty easy to distribute, but it's kind of hard to go backwards. And so the first step to factoring is to find the GCF and divide it out. Now we're dividing because what's the factoring is the opposite of multiplying. And what's the opposite of multiplying? Dividing. So I'm going to do this problem right here. I'm going to give you, it's 3y plus 6. And we are going to factor that. And to do that, we're first going to find the GCF. So let's find the GCF of each term. What's the GCF of 3y? And what's the GCF of 3y and 6? So let's pretend the y wasn't there, because I think you're getting confused with the y. If it was just 3 and 6, if I said, what's the GCF of that? Well, what are the factors of 3? What multiplies to give me 3? There's only one set of factors. So 1 times 3 is 3. And there's nothing else that multiplies to give me 3. So my factors of 3 are 1 and 3. And my factors of 6, well, we know 1 times 6 is 6. And we know 2 times 3 is 6. And there's nothing else that multiplies to give me 6. So if we were to write it out, or you can see it here, what do they have in common? They have a 1 in common, but is that the greatest common factor? Is it the greatest number they have in common? No, they both have a 3 in common. So the GCF of 3 and 6 is 3. Now, though, we're talking about a 3y. So the 3y, it's just a letter, it's just there. Does 6 have a y? No, so they don't have a y in common. So the GCF of these two terms of 3y and 6 is just 3, because 3 goes into 3y and 3 goes into 6. So we're going to take that GCF and we're going to factor it out, which means turn it into a multiplication problem. So we're going to put 3 and we're going to put parentheses because we're turning it into a multiplication problem. And we're dividing it out. 3y divided by 3, 3 divided by 3 is just 1. And did we factor out, are we pulling out the y? No, so we're going to leave the y right there. And then you have to, so we're dividing 3 by 3y. Now we're going to go divide 3 by 6. And 6 divided by 3 is positive 2. So that is factoring out the GCF. I know that seems a little confusing. We're going to just do problems so you get that. If you did put, if you took away the 1, it's still the same thing. 1y and y are the same thing. So one way to check your answer, so if this is my answer, you go back, you distribute. If you distribute and get the same answer here, then you know you did it right. So for instance, if I multiply out, what's 3 times 1y? 3y. And what's 3 times 2? 6. And if this matches the original problem, which it does, then you know you did it right. All right, so let's just try some examples. We're going to factor 3x minus 12. Now, this is a subtraction problem, right? It's 3x, this term minus this term. We're going to factor, which means we're going to turn it in to a multiplication problem, something times something else. You can put parentheses here too if you want. So the first step is to find the GCF. So what is the GCF of 3x and 12. Now, he has an x. Let's start with the variable because sometimes that's even easier. He has an x, but does this term have an x? No. So do they have an x in common? No. So x is not going to be part of our GCF. But what number does 3 that goes into 3 and 12? What do they have in common? So if you write out the factors of 3, the factors of 3 are 1 and 3 because 1 times 3 is 3. And the factors of 12 are, we know 1 goes into 12, 2 times 6, 3 times 4. So these are the factors of 12. You don't have to write them out if you know in your head. What they have in common is a 3. So we're going to factor out 3. That's our GCF. Oops, I should put it there. So the GCF, 3 goes into 3x, 3 goes into 12. So we're factoring, which means we're doing the opposite of multiplying, which is division. So you're going to take 3x, you're going to factor out the 3. So you're going to divide here. 3x divided by 3 is 1x. 3 divided by 3 is 1. And then the x you just bring down because you're not factoring it out. And then you do this guy. It's actually, you can read it as minus 12 or negative 12, but you're dividing that. So I read it as negative 12. Negative 12 divided by 3 is negative 4. And that is factored. If you were to check your work, you would distribute out. Let's check our work. So this is my answer. This is factored form because it's now a multiplication problem. It's now 3 times 1x minus 4. You can distribute. What's 3 times 1x? 3x. And what's 3 times negative 4? Negative 12. And this does match the original problem. It matches this. All right, this one, 7x minus 7. Now we're factoring. We're turning it into a multiplication problem. So we got to figure out what the GCF is here. Now this one might either really confuse you or you might be like, oh, I know what they have in common. Just by looking at it, what does 7x have in common with 7? They both have 7. So we know our GCF is 7. My slate is not working. So the GCF is 7. Do they have an x in common? No, he has an x, but he doesn't have an x, so we can't pull out an x. So if we factor out the GCF, we're going to bring it to the front and turn it into a multiplication problem. We factor out x from 7x, so you go term by term. So let me just kind of color coordinate it. We're taking out 7x. We're factoring out 7 from 7x. So whatever's left is going to go here. And we're factoring out 7 from negative 7. So whatever we take out, when we factor out 7, it's going to go here. All right, so let's do it. And remember, it's technically division. So 7x divided by 7 is 1x. You don't have to put the 1 because 7 divided by 7 is 1, but you also can just cross it out because 1x and x is the same thing. And then now it's negative 7 divided by 7. Some people want to put 0. They're like, oh, we're taking out the 7. But remember, we're not just pulling out a number. We're factoring it out, which means we're kind of dividing. We are dividing. It's negative 1 divided by 7 is negative 1. I'm sorry. It's negative 7 divided by 7, which is negative 1. I always do that. And then if you wanted to check your answer, this is our factored form. So this is our answer. It's now factored, which is a multiplication problem. If we want to check our answer, we would distribute. 7 times 1 is 7 times 1x is 7x. And 7 times negative 1 is negative 7. And this does match our original problem. All right, this one. The next one might be a little bit more trickier. We got 12y squared and 5y. So if you write out the factors of 12, what number, you can do it in your head, what number goes into 12 that also goes into 5? So you might say nothing. You might say 1. The only factor that goes into 12 and 5 is 1. And you don't even have to pull out the GCF of 1 if it's only 1. But I'm going to put 1 so to not confuse you yet. So we know the GCF for this guy GCF, the only factors that go into both 12 and 5 is 1. But what else do they have in common? Now they have a variable in common. He has 12y squared. Now what does y squared mean? That means 12, and then y squared means y times y. So that means he has 2 y's that are being multiplied by each other. And this is minus 5y, and he has a y. Now, so they definitely have a y in common, and the max amount that they have in common, the greatest common factor among the y, is just y. He has 2 y's, but he only has 1. So the greatest one among them, the greatest number that they both have, is only 1 y. So for instance, if I have 2 fingers, my other hand has 1 finger. What do they have in common? Well, they have fingers in common, but how many do they both have in common? Well, he has 2, but he doesn't have 2. So you can only take out 1 from him, and you can only take out 1 from him. I might have just made that more confusing. But anyway, so let's try this. So the GCF now is 1y. So we're going to factor that out. Now remember, we're taking this term and we're dividing. 12 divided by 1 is still 12. But y squared divided by y is just y. Now, if you remember the rules, it's y squared divided by y. The automatic exponent here is 1. When you're dividing with the same base, which is y, you keep the base and you subtract the exponents. 2 minus 1 is 1. So you can put a little 1 there if you want, but you don't have to. There's an automatic 1. Or you can just think about it like I just did with my fingers. We have 2 y's. We have 2 y's, and we're factoring out one of them. We're taking 1 away, which means we're left with just 1 y. Just not 1 y, just y. So I have that here. And then for this guy, we're dividing. Negative 5y divided by 1y is, so negative 5 divided by 1 is negative 5. And then we have a y here, but we're factoring out the y. So we're left with no y's here. We took it out, just one of them. So this is my final answer. Now remember, how do we check? We distribute. What's 1y times 12y minus 5? Now, if you don't have the 1 here, that's okay, because 1y is the same. If you have 1y and you have just a y, you have the same thing. So you don't have to have the 1 there. 1y times 12y is 12y squared, because y times y is y squared. And then 1y times negative 5 is negative 5y, and that does match. All right, I'm going to do 2 more with some variables, because I'm sure you're like, I have no idea. So maybe you're still really confused. So we're going to try this one. We're factoring out the GCF. Now this one has no numbers. Now you can put a little 1 there, but you don't have to. There's an automatic 1, but you don't have to do that. We want to find the GCF. That's always the first step, is factor out the GCF. So what does this term have in common with this term? By the way, this is a binomial because there's 2 terms. So if you're looking at this, what do they have in common? They have an x in common. They both have x, and they both have y. So if you're looking here, let me actually make some room here. Let's just write out what this really even means. X squared means x times x. Y to the 3rd power means y times y times y. It means you have 3 y's being multiplied. So this term turns into this, and it's plus just an x and a y. This term is the same. So we're factoring out the GCF. The GCF is, what do they have in common? Now, he has 2 x's, and he has 1. So the max, the greatest number that they both have is just x. So we can take out an x. They both have x. And then they both have y. He has 3, but he only has 1. So we can only take out 1 y from each group, because we can't take out 3 from here because he doesn't have 3. All right, so we're going to factor out xy. When we take out xy from this term, now remember, we're dividing. What's x squared divided by x? So it's x squared divided by x. Remember, when you have the same base, you subtract the exponents. So you're left with just x for the x. And then y to the third divided by y is y squared. We have 3 y's. We're factoring out 1, so we're left with 2. And then we got plus sign in the middle. And now we're going to factor out xy from xy. Well, what's xy divided by xy? Some of you might say 0, but it's not 0. What's 4 divided by 4? 1. What's 5 divided by 5? 1. What's 6 divided by 6? 1. What's xy divided by xy? 1. So it just turns into 1 here. And it's also because this exponent, if you really want to see the math, remember you subtract the exponents, so x divided by x, you think they just cancel, but really it's x to the first power divided by x to the first power. What do you do with the exponents? You subtract them. 1 minus 1 is 0. And what's anything to the 0 power? 1. All right, so this is my answer. I know that might be a little confusing. And the last one, this one is 3 terms. So we got 1, 2, 3. It's still the same thing. You're still just trying to take out the GCF, the factor out the GCF. So let's look. Now we have to figure out what all 3 of the terms have in common. So what does this term have in common with this term and have in common with 15x? Now, see if you could do it in your head. Do you know what number goes into 3, 6, and 15? What do they all have in common? Now I'm just going to show you the factors of 3. This is 1 times 3, and that's it. The factors of 6 are 1 times 6, 2 times 3. So those are the only factors of 6. And the factors of 15, what gives me 15? Well, 1 times 15, 3 times 5. And that's it, right? Those are the only factors. So here are the factors of 3, here are the factors of 6, here are the factors of 15. We have to figure out what they all have in common. So they all have a 1, and they all have a 3. That's it. So out of those 2 numbers, which one's the greatest number? 3. They all have a 3, 3, 3. So the GCF out of the numbers is 3. And then, I don't know if you noticed, but they all have an x. He has 3 x's. 1, 2, 3 being multiplied. X to the third means x times x times x. He has 2 x's being multiplied, x times x, and he just has 1. So you have to take out what they all have in common. You can't, so you might say, oh, well, this is the biggest number, 3 of them, but you can't take 3 from 1. You have to be able to factor it out and pull it from each term. Each term has to have it. So we can't divide x divided by x to the third. So we're only going to take out 1. They only have 1x in common because he only has 1. So we're going to factor out 3x. When I take out, I'll just put it right here. We're going to factor out 3x, turn it into a multiplication problem. And so it's 3x to the third divided by 3x. Well, 3 divided by 3 is 1. X to the third divided by x. Remember, you subtract their exponents and you get x squared. You have 3 x's and you're factoring out one of them. So you're left with x squared. Then you're going to do this term. 6 divided by 3, and it's positive 6 divided by 3, so it's positive 2. X squared divided by x. Remember, you subtract the exponents, so you're left with just 1. And then negative 15 divided by 3 is negative 5. And then you have an x, and we're factoring out that x. We took it out, so we're not left with an x here because there's only 1 here. So this is my factored form. We